In this video, I will talk about running Kubernetes on cloud and the benefits of a managed Kubernetes service. So let's build a case where you and your team are developing a microservice application with database that will be deployed in Kubernetes cluster. You want your application to be available from a browser. It's your domain name with secure HTTPS connection. Plus you have some requirements like security for your whole cluster setup, of course, and the data persistence for your database. And because you want to do it properly, you want to have development and production Kubernetes environments that are the same, so you can properly test new features before releasing them. So this is your wish setup, and you want to get this as efficiently as possible without wasting a lot of time and without having to spend your whole time learning and figuring out every piece of technology. So bear that setup in mind while we go through the following concepts. So let's dive right in. First of all, where will your Kubernetes cluster for an application be deployed? Consider when you want to set up a Kubernetes cluster on a cloud platform like Linode. How does this actually work? Now, there are two options to do that. Option number one is to spin up, let's say, 6 Linode server instances, and you can set up your own Kubernetes cluster from scratch, meaning you install control plane processes on 3 nodes and make them control plane nodes, then install the worker processes like kubectl, kubeproxy, and container runtime like Docker on the other 3 and make them into worker nodes. And once you have set them up, you have a Kubernetes cluster. And now you can deploy your applications in the cluster. So the whole Kubernetes cluster, including the control plane and worker nodes, are your responsibility to manage, secure, backup, and so on. So you have to manage that cluster completely yourself, including the underlying infrastructure and the servers. It is doable, but it's a pretty big overhead to install all these binaries and processes and to put the cluster together if you just want to create a simple cluster to deploy your applications. The option of creating cluster from scratch on cloud instances is not very practical because, as I mentioned, you want to get things done fast and easy and don't want to spend too much time on setting things up and figuring it all out. So as an alternative, cloud providers like Linode also offer what is called a managed Kubernetes service that does a lot of heavy lifting for you. On Linode, it's called a Linode Kubernetes engine. So how does this work, or what does it actually represent? So you don't have to create cluster from scratch. Most of it is done for you automatically by Linode platform. So when you create a Kubernetes cluster on LKE, Linode Kubernetes Engine, you just choose how many worker nodes you want. So you just care about worker nodes. You will get, for example, 3 worker nodes with all the processes, including Docker container runtime, pre-installed. So you don't have to install any of this. And you will get them up and running in no time. So what about the control plane nodes? Who creates them? Or who manages them, and why are they there? The thing is, Linode creates the control plane nodes in the background when you create the cluster. But you don't even see that because it's completely managed by Linode and it's not your responsibility anymore. So you don't have to manage and secure and do all the configuration on it. And that's one advantage. But it also means that you only pay for the worker nodes now. You don't pay for these extra couple of nodes that run as your control plane nodes. That eliminates not only extra costs, but also a lot of effort and overhead, because you can literally just get started in minutes with a running Kubernetes cluster. So it saves a lot of time. So let's go through this in more detail. How does this all work and what can you do with Linode Kubernetes Engine? The process is pretty simple. Let's say you create a cluster with 3 worker nodes to deploy your application. On Linode UI, choose your worker nodes with their resources. Linode has server instances of different capacities, so depending on your needs, whether it's a test, development, or production environment, you will choose which nodes you need with how much capacity. Then you select a region or data center where the worker nodes will run. So for example, if you're, let's say, in UK, maybe you create a cluster in your nearest region in the UK. And with a couple of clicks, your Kubernetes cluster will be up and running. Then you connect to the cluster using kubectl from your laptop and deploy your applications, services, and do all these things that you need to do in the cluster. Super straightforward. So let's say you need to deploy a MongoDB database for your Node.js application, and you want several replicas of that. Now, database applications need data persistence, right? To save that application data. And if you have 3 replicas of a database, you need persistence or storage for all 3 replicas. We already covered data persistence in a separate lecture, so you already know there are different types of storage. Like there are cloud storage providers, there is NFS, local storage on the nodes themselves, etc. And the storage you have to configure yourself. Kubernetes doesn't do that for you. So you would have to create that storage, the physical actual storage, and make it available for the cluster resource like database. Then you would have to create persistent volume components with the storage backend. And now you can attach these volumes to your database pods. Well, Linode has its own storage, Linode block storage, that you can use to dynamically create the volumes. So you don't have to set up and configure anything. You don't have to create the physical storage and then create volumes out of it and connect them, etc. You just use Linode's storage class, and Linode will create the persistent volumes with the respective physical storage in the background automatically. And when you deploy your database application, the storage will get attached to your database pods. And you will see all of this in a demo part in detail. So you have a very little effort here as well. Of course, it's good to know how it works, but you don't have to do much here. Okay, so now you have your Node.js application, let's say running, as well as MongoDB database application with replicas and its storage configured. So now we need services and access from the browser through Ingress, which is part of Kubernetes that basically manages routing of incoming requests, like from a browser to internal services in Kubernetes. So in our example, you would need to install and run Ingress controller in your Kubernetes cluster so that you can configure Ingress rules that will then route the incoming traffic to your Node.js application. To understand the concept behind this, in a cloud environment like managed Kubernetes service or in a Linode Kubernetes engine, how does this setup work? How will Ingress get that incoming request? And it happens through Linode's node balancer. So on cloud platforms, you have cloud providers' own load balancer implementations that gets in front of the Nginx Ingress controller. So that becomes the entry point in your cluster. So let's see how that works. Linode's node balancer is, as the name says, a load balancer for your worker nodes, where nodes are the Linode server instances. So say you have 2 Linode instances, one runs a database application, another runs a web server. And you expose the web server using a public IP address. So browser can send requests directly to the web server. The problem is you can't scale this application. If you suddenly start getting a lot of traffic, your web server will become a bottleneck. Also, if you make changes to the web server, like reboot it, reconfigure it, etc., your application becomes unavailable. Instead, let's say you add a node balancer in front that takes the incoming request and directs it to the web server. So node balancer will get the public IP address, and web server will be hidden away and accessible only at private IP from the load balancer itself. Now you can add multiple web servers under that load balancer can forward the request to. So you can scale your application up and down without users even noticing anything. Now you have an entry point to your application that you set up once and just leave it. And it works. It's just there to accept the requests and then redirect it to one of the web servers. You can also configure session stickiness with Linode's load balancer, which means if user authenticated on one server that keeps sessions in the memory, meaning only that web server instance has the session information and knows the client, you can configure the node balancer to forward the next request from that client to the same web server, instead of randomly picking or passing the request to any server. So the same client will always land on the same backend. And trust me, if your application keeps sessions in memory, this will be the first thing you're gonna be asking how to solve. So this feature is very helpful. Now, obviously you need your connections to be secured. So you can also configure the node balancer with SSL certificate pretty easily. So it can accept HTTPS requests. On Linode, you can do that using a plugin called Cert Manager, which basically helps with managing SSL TLS certificates. Remember, we don't want to spend time doing everything ourselves. We want to delegate most of this stuff to technologies. So in this case, you can get the certificate and store it as a Kubernetes secret and use it to secure the connection to your cluster. And as I said, the concept you learn on Linode, you can apply on other platforms as well. So far, I've used 3 or 4 different cloud platforms, and the usage concepts are pretty similar. It's just that some platforms are better in doing certain things. Now that you have a successful setup, your application is scaled and available through browser. Users can now use it. And let's say when you created your cluster on LKE, you selected region, let's say Dallas, USA. So that's where your cluster or your work nodes are running. Suddenly you notice most of your users are accessing your application from Europe and India, let's say. This means that connection speed is not good for your users because the servers are located geographically too far away from them. So you want to host your application in closer proximity to your users. That's where the availability zones of a cloud provider come into play. Linode has data centers across the globe in a number of physical locations, also known as availability zones, where you can run your nodes. So if you want to roll out your application for German and Indian users, for example, you can simply select the data center locations near them. Now let's say everything is set up on LKE, your application is running, you have it in multiple data centers, all looks good. Your team or company decides, you know what, we would like to move our data and all the sensitive information from the cloud platform to our private cloud. And also there is this new feature of our application that will be most efficiently done using a specific service in cloud platform B, whatever that is. So basically you want to migrate part of your application setup to a private cloud and part or just one feature to another cloud. Usually what happens is when you set up your Kubernetes cluster on a cloud platform, you end up using its services like native load balancers and storage or some APIs that are specific to that cloud provider. So your application or parts of your application gets closely tied up to that specific cloud provider, and you can't migrate easily. You may need a lot of reprogramming and reconfiguration to move parts of your code or the whole application away from the platform and migrate it to some other place. That's called vendor lock-in. An obvious reason for that is, of course, cloud platforms want to keep the companies tied to them by providing these useful super services, but which are cloud specific, so you can't move your application easily afterwards in case you need it. Another point is, let's say your setup grows in size, you deploy more and more services, your infrastructure configuration gets more complex, and your DevOps team grows as well. In this case, you would want to automate as much as possible. So you may automate creating, configuring, tearing down, doing all sorts of things with your infrastructure where your cluster is running, and also automate deploying your applications and services. And you can do that using automation tools. So for example, tools like Terraform or Ansible, which are automation tools, have modules or providers or whatever they're called in their respective tool that can connect to Linode platform to get access to its resources and then let you automate your DevOps work to again save time and work more efficiently.